Welcome to the third part of this series, where we'll look into matrix by matrix multiplication, basically multiplying two or more matrices together. And our question for this part goes as follows. Matrix B is a 3 by 3 matrix, matrix A is a 2 by 2 matrix, and matrix C is a 2 by 3 matrix as given in the intro video. Before I show you the values for these matrices, it is important to note that finding the dimension of the resulting matrix will save you from errors, as this concept can be very tricky. For instance, if asked to multiply a 3 by 2 matrix with a 2 by 2 matrix, what do we expect as the dimension for the resulting matrix? When we do this, then it will be safe to move on to multiplication of the matrices. For finding the dimension of the resulting matrix, let's begin with B squared. B squared means B times B, and B is a 3 by 3 matrix, which that is equal to this. So to find B squared, we have to multiply a 3 by 3 matrix by another 3 by 3 matrix. The first matrix is called the multiplier. That is the matrix with which we multiply, where the number before the multiplication sign represents the number of rows, while the number after the multiplication sign represents the number of columns. The second matrix is called the multiplicand. That is the matrix to be multiplied. And similarly, the number before the multiplication sign represents the number of rows, while the number after the multiplication sign represents the number of columns. First of all, to determine if the multiplication of the matrices is possible, we have to check that the column of the multiplier and the row of the multiplicand are equal, as it is in this case with 3. So once they are equal, then it is possible to multiply the matrices. Now that we know this, we find the dimension of the resulting matrix by taking the column of the multiplier and the row of the multiplicand and cancelling them out. Then we are left with these two values, forming the dimension of our resulting matrix. In this case, we get a 3 by 3 matrix. We do the same for AC. A is the multiplier and it's a 2 by 2 matrix. And C, which is a 2 by 3 matrix, is the multiplicand. Finding AC implies multiplying a 2 by 2 matrix by a 2 by 3 matrix. So first, we check that these two values are equal. Then we cancel them out if they are. Then these values here give us the dimension of our resulting matrix, which is basically the row of the multiplier and the column of the multiplicand. Finally, for CA, we'll notice something new here. C, the multiplier, is a 2 by 3 matrix, while A, the multiplicand, is a 2 by 2 matrix. So when we try to multiply them following the order, we'll see that these two numbers here are not the same. And that already tells us that CA is an invalid question. So given AC and CA, since AC is valid and CA is invalid, we can conclude that these two are not equal. Actually, CA cannot even be evaluated, but if it could, it will still not result in the same matrix as AC. If you recall from basic math knowledge, when you multiply 3 times 5, for instance, you should get the same answer for multiplying 5 times 3, which is 15. So we say that multiplication of numbers is commutative. However, a certain matrix multiplication, AB, will not be equal to BA. So we say the multiplication of matrices is non-commutative. Now let's move on to actually multiplying these matrices. The first thing to note is that there is an order of flow we must stick to. For the multiplier, we must always go in the horizontal direction, that is the direction of the row from left to right. And for the multiplicand, we must always go in the vertical direction, that is the direction of the column from top to bottom. This forms an inverse L. It is only by following this order that you get the correct values for the final matrix. So given P times Q, for instance, as follows. For P being the multiplier, we go in the horizontal direction from left to right. And for Q being the multiplicand, we go in the vertical direction from top to bottom. Let's see this in action with these letters. Using our order of flow, we take the first row in the multiplier and the first column in the multiplicand. We multiply the first values A and E and the second values B and G. Then we add them together to give A dot E plus B dot G. Then still with the first row in our multiplier, we jump onto the second column in our multiplicand. We multiply these two as well as these two here. Then we add them to give the next value. Now we jump to the second row of the multiplier matrix and go back to the first row of the multiplicand. We multiply these two, the first values and the second values, then we add them together to get this. Then still on the second row of the multiplier, we jump onto the second column of the multiplicand. We multiply these two, then we also multiply these two, then we finally add them together. With all this, let's look at actual questions. B square is basically multiplying these two 3 by 3 matrices together. So let's begin. We take the first row of the multiplier and the first column of the multiplicand. We take their first values and multiply them. Then we take their second values and multiply them. And finally, we take their third values to multiply them. Then we add this up and place them here. Still on the first row, we move to the second column of the multiplicand. We take their first values, multiply them. We take their second values, then multiply them. Then we take the third values and multiply them. Then add them together to place them here. You can see their first values are highlighted with blue. Their second values are highlighted with a pink circle. And their third values are highlighted with a yellow circle. Then still on the first row of the multiplier, but the third column of the multiplicand, we take their first values, multiply them, take their second values, multiply them, then take their third values and multiply them. Then we can add this up together. You can notice the flow of the arrangement from left to right in our resulting matrix. Then we move on to the second row of the multiplier and go back to the first column of the multiplicand. We multiply the first values together, we multiply their second values, and we multiply their third values. Then we can add them and place them here. We remain on the second row of the multiplier but move to the second column of the multiplicand. We multiply the first values, we multiply their second values, we multiply their third values, then add them together. Then still on the second row of the multiplier, we move to the third column of the multiplicand. We multiply their first values, multiply their second values, and multiply their third values. Then we add them together and place them here. Now we move to the third row of the multiplier and go back to the first column of the multiplicand. We take the first values and multiply them together. Then we take the second values, multiply them together. We take their third values, multiply them together, and add this up to place here. Still on the third row of the multiplier, we move to the second column of the multiplicand. We multiply their first values, multiply their second values, multiply their third value, and add them up to place here. Then we move to the third column of the multiplicand, but stay on the third row of the multiplier. We multiply their first values, multiply their second values, multiply their third values, and add them up to place here. At this point, we can multiply all values where necessary to obtain this. The next step is to open brackets, and if you have trouble determining the final sign after opening brackets or adding or subtracting negative numbers, then I'll recommend you watch this video. After opening brackets, we perform the addition and subtraction to obtain our final values for our resulting matrix as this. And as we can see, it is a 3 by 3 matrix as we determined initially. To find AC, we have to multiply these two matrices together. Now, following the same technique, we take the first row of the multiplier and the first column of the multiplicand. We multiply their first values, multiply their second values, and add them together. Then we take the first row of the multiplier with the second column of the multiplicand. We multiply their first values highlighted in blue. and multiply their second values highlighted in pink, then add them together. Then we take the first row and the third column of the multiplicand. We multiply their first values, multiply their second values, and add them up together. Then we move to the second row of our multiplier and take it with the first column of our multiplicand. We take the first values, multiply them together, then the second values multiply together. When we add them, we place it here. Then we take the second row of the multiplier with the second column of the multiplicand. We multiply their first values, multiply their second values, and add them up together. Then we take the second row of the multiplier with the third column of the multiplicand. We take their first values and multiply them. Then we take their second values and also multiply. Then we add them up together. Now we can multiply all that needs to be multiplied to get this. Then we add or subtract as required to arrive at this as the final answer. Thank you all for watching.